Hi and welcome to the Tech Geeks video. My name is Paul. Today we're going to do a deep dive into the Ubiquiti Enterprise Fortress Gateway. This is Ubiquiti's start into the enterprise routing space and maybe the start of some move more consciously into the cybersecurity space. So this is going to be a deep dive. I hope that I can show you maybe some of the features, how I would use this, where I could use this in comparison probably with some of the mainstream vendors that I've been involved with since the late 90s. So we're going to do some comparisons here with Sophos, with SonicWall, with WatchGuard and Fortinet, which I think are probably some of the entry point players for this, certainly on performance and price wise. We want to try and see where this fits in. Has it got some shortfallings? How does it perform against the others? Obviously, this is a subscription-free model. You can add on additional IPS or IDS detection signatures. I'm in Australia here recording this in October 2024, and we don't have access to that here. So I'm not going to be covering that bit. I think they're between 75 and 100 US a month, depending on what you go for. But I do think we're going to see development over these next 12 months. So I'm more basing this on a subscription-free model, a one-off purchase. Where would this fit? What could this actually do in your network? Look, there are other videos where people have done, what's in the box and stuff. You can find some of those on our YouTube channel. It's not about this. This is more of a technical deep dive of how I can actually put this in our network, how we can do NAT rules, how we can do port forwarding, multiple IP addresses from our ISP, even when we get a DHCP IP address. So I'm going to walk through these. What I've tried to do is condense this so that the first portion of this is all just concentrating on the Ubiquiti, and then I'm going to go on and show the other firewall vendors and how they relate back to some of those sections. So this might be a TLWD, too long didn't watch, so please do maybe just look at the chapters and pick out what is relevant for you. I'm going to try and cover as much as comes to my mind as I go through this. I don't have a script, I don't have a plan, and please understand this, we don't get given IDs to do reviews. I normally beg, borrow or buy every piece of Ubiquiti equipment that we do. If there's no axe to grind, there's no promo thing to show on here. This is always for me about how can I make this work? Can I make it work for my customers? Where is it cost effective? So I can see some of the shortfallings, but I can also see quite a few of the positive, and I want to show you that comparison. So let's head off and start a basic just orientation around what we've got, and then we'll start getting to some more of the juicy bits. Okay, so we're going to head off just very simply now to start with, just to look around this. Now, if you are used to the Ubiquiti control panel, then this is nothing unusual for you. The EFG, the Enterprise Fortress Gateway, is also a Ubiquiti network cloud controller. All right, so this will manage your access points, your switches. Those are the key things that we see come after this. It's not a full OS console, Ubiquiti OS console, so it's not going to manage Unify Protect for your cameras or Unify Access or anything else like that. And where can we see that? Well, we can see that in here and in control plane. All right, so we can see we can only have network running and inner space. If you want, and you've already got a Ubiquiti controller, then you can look at the UXG Enterprise, which is this model. So everything that we do now is covered in that, but excludes the network management side of things. This is a meaty device. You'll see some of the performance we do on it later. So it has got the grunt to be able to do exactly what Ubiquiti say it will on the tin, but it has a place potentially if you've got 10, 20, 30 access points, a bunch of switches, why not run it all through this? So this at the moment is sitting in a sort of inert state. We haven't done much config on it, and it hasn't really much had traffic through it. We're going to introduce that as part of the video, and you're going to see more of that as we go along. So that's why we don't really have much happening in here. We have our topology, very simple. This is just connected to the internet and this device at the moment in time. And if we had other Ubiquiti devices, the same process for adopting them and everything will appear in here. So I'm not going to be covering that. I'm more interested in our NAT, our port forwarding, all of those bits and pieces. All right, our clients, again, like I said, there's no real traffic running through this. There is nothing here for us to report on, but hopefully we'll have a look at that a bit later on. Our switch ports, what do we know about this? We have two 2.5 gigabit Ethernet ports. We then have two 10 gig SFP ports, which obviously you could run 10 gig fiber on, or you could bring that down to an RJ45 10 gig adapter if you wanted to. And then we've got two SFP28s, which always confuse me because that is 25 gigabits a second. Somebody did explain to me what it all meant at some period in time, but yes, these are SFP28, so they will do 25 gigabits a second. So our port manager, if you've not done this with before, our port manager allows us to change a whole load of config on here. So manual, we can change the link speeds, we can apply port, we can apply speed, which we'll talk about a little bit later on, and rate limiting, and we can do loop protection if we want to. And we can potentially add specific VLANs and those type of things onto a port if we want to later on. So we will cover a little bit of that so you can see how this maybe works as more of a router as well. We'll come then in insights. So insights we're going to see a little bit more of as we progress through this video. I think it's important here to just understand this is not connected yet, and we'll pick this up as we go along. The viewer basically shows us what's actually running in here and what basic information has been set up. So it's just a nice quick way of seeing what's going on and any AI detections, and we'll cover that in a bit. Inspection is where a lot of the juicy stuff is going to happen, and we're going to look at that in due course. So allowed, again, as we start to get some traffic through here, we're probably, if we did a week ago, maybe a month ago, when did I last use this, you can see some of the information we can already grab from when I was testing this, and we'll see how this goes as we add some computers behind this. Even queries, which is really good. I set this up to actually query strings that were being used and report on them. So again, some quite useful information for being able to track and see what was allowed and see if anything was actually blocked. And we've got our geolocation here to again show where traffic is moving in and out from these locations, and we can just choose a country by hovering over it and blocking it as well. So this is more of a graphical representation of what is going on. Our log viewer. All right, all of our normal stuff on here, things that have gone wrong, things that are not happening. Security detections, we'll look at these. This is an IPS detection of a machine that shows that a peer-to-peer was happened because I had some record of that going on. Shows maybe when the last updates were done, when the admin logged in, what clients are on the network, whether any access points which we've not got, triggers anything that was set from those access points, and the hosts information that we can see. Like I said, a lot of this is not actually going to be having any useful information because we've not set this up. And then our settings, which is really what we're now going to work through, just so that I can show you how to get the basics of this in place and in your network. We're going to actually add this currently into our network. We're going to add a failover internet connection. So we're going to migrate the internet over using that connection first, which will allow us to move the whole office. We're going to add some VLANs to this, so again you can see those features and how they're actually done. We're going to move this in an office environment, so we're actually going to move the office, so we'll push them over to the failover first, and then we're going to disconnect our main internet connection and move that across. I'll show you what's needed there potentially if you're on an NBN circuit as well. So we're going to set off down the settings section next. So I'm going to be moving some of these settings from a office-based WatchGuard that I have here, but also a temporary Cloud Key or Cloud Gateway Max that we've had in as a test. Now, just before we head to the settings, if you're new to this, then Ubiquiti, everything can be managed either directly from a web browser, or you can see my URL up here, says unify.ui.com. Unify.ui.com is a consolidated place where you can see all of your what are called OS consoles, all of the devices that have management capabilities built into them. And you'll see here we've got plenty in this demo account. And you can see I've got my EFG over here, and I've actually got my cloud gateway in here. I've also got some other self-hosted ones like this one here for Spinel. And then we've got other client and other test equipment based over here as well. So these are great and simple ways of being able to manage it and collect it together. So if you've got multiple sites together, then this becomes really, really easy to be able to do VPNs from here or manage to see how all of those sites are working. So you may have an EFG in the central location, and you may have a UCG max at 10 or 15 different sites that we're working with one customer of an install like that, and then you can actually bring them all in a VPN, but you can also manage them all individually here. So I'm just now going to go into our gateway max here, and we're going to move some of the settings across. Now, as you can see, the menu is almost identical across here, and we're going to start picking up a whole lot of this information once the EFG becomes the master of our network. Now, it's going to be a bit of a process because I want to show you how the speed and everything else works as we go, which I want to show you before those changes are all fully made. But what I really want to do is show you first in our networks, we want to start working on our network recreation, which is what I've got here. So let me just start by working through networks with you, and then we'll see how we can build on that as we go along. So we can create networks as we go, and each network can be its own physical network or bound to a switch port or a VLAN. So at the moment, let's just work on the default network that's created here. And we're going to do our speed tests and everything from this just so that we know that it all works. And I can show you before we move everything else live, but you get a feel for how these bits work. So at the moment, it's set, you'll see by standard, it's set to auto scale. And builds the network and increases it as it goes. My suggestion probably in these days is that you maybe go a little bit bigger than a /24. You maybe get yourself a few extra IPs, more like 500. It's surprising how quickly we get through just 254, especially if you're in an office with IoT devices and those type of things. But you can obviously set this to be whatever you like, or you can actually choose to not auto scale this, and you can just manually work on the config that you have. So let me just take that back and auto apply that if I want to. All right, and now I can physically put in here and say, okay, I only want this to run on a network in a certain way. All right, and I don't want it to expand automatically. So in this setup here, I'm going to have this set of IPs. I'll probably just leave it on auto scale here just to show you how those bits work, because it's sort of irrelevant at this starting spot. But the things I want to key in here, in auto, you get all of the settings that are shown just here that are a little bit faintly hidden. I like to run this on manual. Why do I like to run this on manual? It gives me a slightly better control over what's going on here. But I've also found some unique little things that I like to have slightly differently. So ping conflict detection is one that I found recently, which was quite interesting. So I like to turn this off. When if in a test environment like we have here, we've got a number of firewalls. What ping conflict detection does is it allows the DHCP server on, this is what I've seen, might not be totally right, but this is what I've seen. The DHCP server is allowed to allocate an IP address to a device that is requesting it via DHCP. But to make sure there's no other conflicts on the network, it actually sends a ping packet to that device and expects a response. When it gets a response, then it allows routing to properly happen. What I've found is I can get to the device on the LAN side of the EFG, but if I was to try and get that device to go out to the internet, it actually fails. So I'm pretty sure that there's some sort of reverse ARP or ARP poisoning happening, ARP being the correlation between an IP address and a MAC address and an IP address, that's actually allowing it to work on the LAN but not allowing it to travel through the device and therefore avoiding conflicts. So I like to turn ping conflict off. Default gateway, probably that's going to be set on auto for you. DNS server. DNS server, this might be if you're in an Active Directory environment, then you might have your internal DNS server. Probably if you're an Active Directory environment, you'll probably be using your Active Directory server to also do DHCP. So in this instance, you would have actually used this option and turn DHCP off completely, so that it's not actually running with it, and would have just given it an IP address, and you would have updated your gateway information there. All right, so let's just reset this. So I like to have this set. Obviously, plenty of other options you can put in here. Domain name, again, if you're on Active Directories or you want to map some stuff out, then you're going to put your domain name in there. That might be domain name.local if it's your Active Directory domain name. And if you've got any specific DHCP commands that you have in here, maybe for VoIP phones or anything else like that. So as part of this, and I'll show you a bit later on how all of these bits come together, I'm going to have content filtering turned off. We're not having isolate the network turned on, and this is the local or the default LAN, so we can't turn those bits on anyway. So this is my basic network now configured. So I want to show you probably next the performance that we get. We're not going to be testing the internet. That's not so relevant for us in this point in time. We've got an internal testing setup, which I'll talk about in a minute. And I just want to see how much data I can get through this device because it says that it can do, 12 gigabits a second of SSL. It says it can do, 24 gigabits a second or so of normal throughput. I don't really mind. If we get over 2 or 3 gigabits a second, this puts it in an incredible contender for many of those vendors that we were talking about, whether it be Sophos or WatchGuard, Fortinet, or SonicWall, because the price point is so attractive. So let's go on and just do a little bit of performance testing now for you so you can see how this actually works in our lab environment. Okay, so we've gone through our basic there of our default network. I've moved a test server into that network, and you can see it's got a lease showing on here. This is really, really interesting. I love some of the versatility already on this. So again, I can choose that test server, as you can see, that I've got. It's worked out that it's part of Hyper-V that we're running on. It's already known what IP address it's been allocated to it, and we've already got some information from it. From a simple to manage, because we're already seeing this traffic, we can already just choose some options here to block and everything, which we'll cover a little bit more in more detail. But what I do like in here is the option immediately to set a fixed IP address. So I can now choose immediately to fix that IP address, or I could set a local host name for it as well if I wanted to, if this device was doing DNS. And I can now choose apply down here. And now essentially, and there are two ways of setting static IP addresses. I'm aware that you can either go and set them manually on a device, or you can leave that device on DHCP and then set that DHCP server to always give out that IP address when it matches that MAC. That is one of the easiest ways of doing it, and this is now just easily making that happen, and that every time it reboots would always get that same. I can now rename it on here, so maybe I'm going to call this Linux test server. All right, I won't necessarily keep a fixed IP address, but I can now just apply that. So now anywhere where I see this device listed from now on, I'll actually see it as the Linux test server. So this could be useful if you've got printers you want to rename or anything else like that. It's showing us obviously how many IPs and everything have been used here. So just to cover simple the overall items here. If you need broadcast stuff, that's what this is for, and you can add in other networks that it's allowed to broadcast if you've got VLANs or whatever. And if you want to drop or port, do some of the forwarding there. I'm not really covering those areas. That's not really the security and the performance side. What I'm interested in here is the rogue DHCP, making sure that there is not another DHCP on the network. And in our instance, we've enabled jumbo frames. Remember, if you're doing jumbo frames are an MTU, so whatever the maximum transmission unit size. This is where we fragment packets. They get chopped up after that size. An MTU of 1,500 generally designates a 1 gigabit a second connection. When we move into multiple gigs, we often go to a jumbo packet size of over 9,000 MTU. But every device really connected to it, switches, routers, potentially computers, need to support it as well. So generally you don't have an issue, but across our network we've got jumbo frames enabled to just try and help us get the best performance out of the 10 gig, especially when we're doing some of our controls there, so speed tests. Obviously you can enable flow control if you want to, and if you're using 802.1x, you're doing authentication of some of the ports. That can be something interesting for you. Obviously, you do need a Radius server. Radius is basically a glorified spreadsheet of username or IP address, MAC address equal and password often, or equal access to certain things. So you need to set up a Radius server. There are interfaces to interface with Active Directory, not part of Ubiquiti, but general third-party ones if you're wanting to do something like that. So you can use your Active Directory as that authentication table, and then allows it to decide where some of that information is actually going to go to. So we won't bother doing that again, not really covering that as part of this. So we have a IPERF3 test server running. That server is on a 10 gig virtual environment. I've then got a Linux server, which we'll just bring up here. This Linux server again is connected to that 10 gig environment, and it's actually that device that we saw there. So if I do a if I do an ifconfig and have a look, we can see it's 192.168.1.77, and if we come back here, we can see that that's the IP address that's been designated to our test server. Now, I'm trying to do this as easy out-of-the-box test for you. There's plenty of other people who've used packet and congestion and traffic generating systems to see how much you can get through this device. I just want to show you what we can get. Remember, this is a 4,000 Australian dollar product. This is a $2,500 US dollar product. If we compare that to some of the things in this space, it is very significantly interesting lineup. When we start to talk about that, we talk about a higher end, maybe if we look at a Sophos device, an XGS 136, that tops out when we've tested at about 600 megasecond. With all the services turned on. So then we start to move into the XGS 2100 bracket for maybe a gig, but then again you need subscription services on the top of it, and you're going to start to talk about 8,000 Australian dollars as you start to hit that. Similar, maybe a 40 gate 100F, similar sort of price bracket. A SonicWall probably not far off that as well. WatchGuard maybe just very slightly cheaper. But in performance stakes, this is what we want to give you some benefit or balance against. So we're just going to run a speed test across our network. So this is just going to send 5 simultaneous streams and just see the maximum speed that we're going to get through this device. You can see we're averaging about just about 6 gigabits a second. Now, I've seen tests on the internet of people getting 20 odd gigabits a second through this, and that's great. You can join multiple SFPs together into a lag or whatever and give you a faster throughput. I understand that my test servers are probably not the best in the world. I've not invested tens of thousands to or even thousands of thousands to make these. These are just to show me what's here. But for me, any firewall that is already doing 6 gigabits a second at the 4,000 Australian dollar mark is a really good, and it's doing what it says on the tin for that. But I have seen tests where these people are getting over 10, 15 or 20 gigabits a second without any content filtering on it. So what do we want to do now? Well, we want to start just to see our performance, because we're going to just stay in this performance section for the moment. So what we do have, if we go in here, is we have the option to move some level of content filtering onto this. So I just want to turn that on this device and want to run that speed test again. We're just trying to see, is it having any performance impact, because it's essentially that has to use CPU and RAM, all right? So we're actually seeing no real difference happening there, all right? So I'm happy with that. So let's do another one. Let's do security. Let's turn on intrusion prevention. So let's base it on intrusion prevention. And in fact, looks like I actually still have this turned on. So this is actually already with everything running on here in high is what we're actually getting as that throughput. So maybe let's just do that backwards for you. So let's turn off intrusion prevention. Let's go back to our networks and let's turn off content filtering as well. All right, I don't think you're going to see much difference on this because I think our tester maxes out at about 6 or so, it's about 7 gigabits a second. So I just wanted to show you what you're getting. So even with content filtering on, even with intrusion prevention running, you are getting 6 gigabits a second. You can see we're getting maybe close to 6.5 gigabits a second. Like I said, plenty of other tests out there that have seen this faster, but this is out of the box. I want to just show 6.5 gigabits a second to me is great performance at the price value. So with content filtering and everything on, you can see what it's doing. Now we need to just think about how do we engineer something different to give us an idea of what happens when we turn on what is called deep packet SSL inspection. So we will cover all of this fully in the rest of the video, but the piece here really is in security. We call it Next AI. So Next AI, next generation AI, is about unencrypting. Why do we need this? Well, 85% or over 80% of websites have HTTPS in front. That means we can only read the packet header, so we can only know the site that was first requested. We can't see inside that packet once that HTTPS session has started, because essentially it's a VPN. So what we want to do is we want to do unencryption of that traffic. If we can unencrypt that traffic, we can look inside it and we can make sure nothing malicious is happening. Now, there are some ramifications on how we roll that out. You do need a trusted certificate on every device. And that's where maybe this is still not quite mature enough in its exclusions, but we will show you, and I will walk you through that bit as we go along. But what we want to do is really just see what performance we get. Now this becomes a little bit more tricky because now I need a web server, and that web server needs to deliver me an SSL based website, and so I've got overheads of that. So I really, again, when we look at products from other vendors that are in this price bracket, we're probably seeing 600 or 700 megabits a second on average when HTTPS is truly enabled and running. So I'm just going to go and make a couple of changes to this test environment so that we can actually get this set up. What I want to do is move this admin server, or this test server that I've been running here, also runs an open speed test server. So I'm going to move this onto the WAN side of the EFG, and then I'll come back to you and show you how I get this all working. Okay, so moving on from a network speed test, I want to try and show you how we can do this with HTTPS. It's a little bit more tricky because we need to get certificate inspection happening. Certificate inspection happening comes from this Next AI. We're going to cover this more in depth as we go through the video. I'm going to show you how to install the certificates, what it looks like with and without. I've just left it on simple here at the moment. I wanted to inspect all networks. If we had other subnets or other VLANs, then we could define it there, but we will go through this in detail. Don't want any exceptions. You don't actually have to have anything to be checking in the middle there. Block websites if you want it, if these are insecure certificates or high risk, or however you'd like to do those. Generally, you'll just probably use insecure. Untrusted you may choose, but I'll show you later on what that might involve. So if I just now apply that, so I have a open speed test server. The issue that we've got is that it struggles really to perform when we're delivering so much traffic. So it will max out at about 2.8 gigabits a second. So anything closer to that, I'm happy with. So I can only show you to that speed, but the price bracket that we're comparing these units at, if this does over 1 gigabit a second of SSL inspection traffic, then we're on a winner. All right, so I'm just going to pop over to our test server here that I'm going to run this on. I'm using Chromium. I've already installed the test certificate, the SSL certificate. I can check this by having a look at the actual certificate itself. And I should actually be able to see the URL of the site I'm going to, but then I should see Ubiquiti in the middle. This is called a man-in-the-middle attack. Again, we'll talk about it a bit more in a minute, but basically, this end computer thinks it's making a connection to test.thetechgeeks.com, but actually what's happening is the firewall is intercepting it, and the firewall, or in this instance the Ubiquiti EFG, is then connecting an onward or creating an onward connection to test.thetechgeeks.com. And as a result, it's going to unencrypt the tunnel because the device creates its first encrypted tunnel to the EFG. It can then de-encrypt it, the EFG can de-encrypt it, and then re-encrypt it, and then send it through the tunnel it's created, the HTTPS tunnel it's created from the EFG to the end site. Now, it does need to be running exclusively over port 443. We'll look at a few of the other protocols it supports at the, as well. All right, so I have got that switched over. I've put my test server away from its normal test port of 3001 to 443. Certificates there. So let's just hit a start test on here. I'm hoping that we're going to get somewhere over 2. I don't really mind whether it's in the upload or the download. Like I said to you, this is all down to the power of the web server. I've got this in a limited virtual environment, so there will be a maximum threshold that it can reach. I have seen tests where people have theoretically tested this to multiple gigs. I think you could probably comfortably get over 3 gigabits a second of SSL inspected traffic through this unit, and in its price comparison bracket that blows most of the competitors away, but we can have a look at a bit of that later on. All right, so we've maxed at 2.6 gigabits a second, which is really great. If we pop back to our EFG and go to insights, inspection is what happened with inside it. All right, and we can actually see it does take a little while, I've found, for the logs to actually update. I've just done a refresh there. Here we go, so we can actually see the test that was running, and you can see the upload that was actually happening here as it went along. So that's showing we can actually see inside that SSL tunnel, and we know that actually that is now fully working. So hopefully that gives you an idea of what I can see. Like I said, this is not meant to be, I'm going to prove to you the maximum. In this price bracket, this is doing probably almost 3 times the performance of a unit of a similar value, and to, you know, for where we are, certainly in Australia, to do 1 gigabit a second of SSL is more than enough. Probably if you're starting to move into multiple gigabits a second, then you probably might be in a different cybersecurity space or requirement than Ubiquiti currently is going to offer you. So hopefully that's summed up that little section. We've done performance of actual network throughput, and we've done now performance of SSL. Now we can probably work on and actually start doing some of the other actual config, and I'll show you how to do NAT and everything else like that. So hopefully that's been useful to this point. So in this section, we're going to get this EFG ready to go into the main network. Like I said before, this is going to be taking over from a WatchGuard device. I've also got a UCG Max in here doing a little bit of the work in the interim as well. So we're just going to copy across some of the VLANs. So we're going to copy across VLAN 37 and 39 and just show you how that actually works. So I'm just going to copy across this information. We're going to create a new VLAN. We can give it what's going to be the gateway. I turn it off auto scale because that allows us to control the start and the end address. You see in here we've got 50 to 200. I like to be able to have some spare or some static mapping there if I need to. So let's change this to manual because we want to tag this onto VLAN 37. You've got a few options there for isolating the network if this was going to be wireless. Content filtering, you can fix it to a physical port of the device as well if you wanted to, which we're not going to do. So now we can change this up to be 50 to 200. DHCP options. So in my instance, I just want to be giving out outside. I don't want it to use at the moment the EFG to do all of the requests, although I will show you later on maybe where that could be useful. I'm going to turn off ping conflict detection. I talked about this earlier in the video. This sends out a ping and it doesn't allow full routing to happen if it doesn't get a ping back. Now, we've got a lot of test devices on here that maybe have got firewalls on them or are a firewall and never respond to that ping, and as a result, therefore, don't get internet access. I'm pretty sure that everything else in here is all that is needed. So let's add that one. Oh, again, just need to remember other than the name, VLAN 37. And we're just going to repeat that again for VLAN 38 here as well. this is our first step of actually getting this, or sorry, VLAN 39, this is our first step of actually getting this properly into the network and being able to get it functional. We will make some further changes a little bit later on as we go through all of this. So let's just, this is VLAN 39, take it off auto scale. I'm pretty sure I'll probably do 50 to 200 again. So put it onto manual. I'm going to put this as 39. Here we go, 50 to 200. I certainly want to have this turned off again here. I'm going to set my custom DNS. All right, so I've brought across now the 2 VLANs that I need to bring across to make this work, which was the key that was in there. Hopefully I had tagged that as VLAN. Yeah, there we go. All right, so I had done those bits. This was all set. So now we've got that bit set up, we can just get this ready for the internet side of things. We're going to be using a failover 4G connection. So ideally, I would like to use one of the 2.5 gigabit a second Ethernet ports for that. So I'm going to set that one up there. And then our main primary internet connection will change over to be this port 1. I can't do that at the moment, obviously, because I've not got everything ready to actually go. And I wanted to change that one, but it didn't allow me to change it to the secondary internet connection. So I will change that very shortly, probably to be port 1, once I'm ready to make that final changeover, and this is then ready to go in the network. But what I wanted to do though is I want to make sure that my network doesn't break. So when you're setting this up and you've been testing it, make sure you've got everything from any of your NAT and traffic rules, any port forwarding rules, intrusion prevention is turned off, your content filtering is turned off, any DNS options you maybe have in routing has been reset as well. All right, so I've actually created in here some tests, I think, that I did earlier. No, I think these ones are potentially default created, so they're not actually removable. So that's okay. These are our default ones, which we'll talk about a little bit later on as well. So this is now actually ready to go into the network and take over the function that I need it to, and then once it's in place I can show you how we can build on a whole lot of the other bits and pieces that are in here as well, because this LAN is actually going to change over to a different IP range because of how this is going to go. So we'll need a couple of sets, but the first option we will be doing is to get the 4G connected, which I'm just going to go and connect up now and move over to this secondary port here, and this will then come back up online, but we'll be online just with 4G, and then we can start building the rest of the setup from there. Okay, so I've switched over the settings. So I've removed the internet connection, which was in port 4 here, and I have put in our 4G connection. You can see that the Telstra internet connection has now come up online. Takes a few minutes because it's in failover here. It just takes a little while for it to detect and then switch over. But now I can continue setting this up as I need to get this configured, because I now need to change over the LAN segment on here. This is actually VLAN. It's going to be called VLAN 38 for the want of a better word. We want to get rid of the auto scale on here, and I'm pretty sure that I will need to set it. Let's go and just compare the networks that we've got set over here. All right, it needs to basically match up with this one here so that it can fit into the network. So again, 50 to 250 in this one. So there, that's manual, no, no, no. This one's 50 to 250. All right, so that is going to be, let's just check our options. We've not got ping conflict on. We need to just change this around because I had this before, 8.8.8.4.4, and apply changes. All right, so I've got my VLAN 1, my base VLAN is running as it needs to. This is all set up as it should be. if I come back over to my internet connection here, I don't have I don't want to use an SFP to RJ45 connector here, so I'm actually going to see if it'll allow me to use port 1 for the primary internet, which it will. So we'll then bring in, that's okay, it's offline, I know that it's offline. We've just now moved the configuration there. So obviously with this device you can only have 2 WANs. Some of its competing products will allow multiple WANs at this price bracket, maybe 4 or 5 of them. So I'm sure that that type of thing will come in the future. But this is at least a starting point for what you can see in here. So this is all really now configured, and I'm pretty much at the point where I can actually put this live into the network. Now, when this is going to go live into the network, the key thing to bear in mind here is that if you're on an NBN connection, we're on an NBN Enterprise Fiber. Essentially, I've got an NBN box on the wall. That is keeping a track of the MAC address that is assigned to my connection, and also generally at the ISP. And what we would have done originally, you know, when I was doing this 10 years, 15 years ago, would be in radius, probably still base around that sort of thing. Then again, there'll be a table that will hold the MAC address potentially, or your IP, or the frame that you're coming through on. So often what people do is they change it and it doesn't seem to work. So are you going to take out your old router and plug this in, and it doesn't seem to work? That's because your old router is still stuck on that network. So there are things you can do, potentially rebooting your NBN. I don't recommend you do that. You do that if you want to. If you have a login portal to your ISP, then you want to log in, and there should be an option to do a test or to kick your session, and that will basically kick off the current MAC or the current frame that's connected and allow you to reconnect. So I will do that again when I don't have quite so many staff in the office, and we can actually make this work, and I can change it over. And then I should be able to put a few more bits together on this video, because once that's now then in place, we can now start talking about, you know, getting the content filtering and intrusion prevention running. I can show you how the deep packet inspection is going to work on a computer on the network, and actually get an SSL certificate installed for that, and show you. And then we can run through really things like port forwarding and NAT, and just talk a bit about firewalling, and then eventually go on to hopefully compare this to how some of the other manufacturers handle it as well, and then you'll be able to see whether this fits in your scenario. So hopefully that's been useful. We've got a failover ready, and we should be able to bring the primary online shortly. I'm going to start this video again, and then we will be able to start moving on to some of the other bits and pieces. Okay, so I've waited till everybody's gone home, so I don't get shouted at for taking the internet offline, and so now we're going to do the swap around. So obviously, like I said before, I'm connected here to a WatchGuard firebox. That WatchGuard is then connected out to the internet, actually at the moment via UCG Max. So first what we're going to do, as you know, we've got our failover connection here already connected for Telstra. So I'm going to swap the connections over. So this should mean that the WatchGuard is connected to the EFG, that's connected sort of to the internet, which is, well, it's connected to Telstra. And then at that point, we're actually then going to lose this millisecond. Will probably, the time here to live will probably go to about 43 milliseconds. That will show that we've moved over to Telstra. We're then going to log on. I mentioned this before. If you're NBN or something like that, you actually do need to clear the session that you have. So I'm with Aussie Broadband, and thankfully they have quite a nice little screen that you can log on to. So I'm going to log on, kick my old session off. That will forget about the old router that's in place, and should then allow the connection to come online, and that will be the EFG in the network, and then we can start looking at some of the other bits. So I'm just going to go and leave that ping running. I'm just going to run over to the other room where the server rack is and switch over the cables, and then we'll be able to hopefully see the changeover happen. All right, so let's see in the long term what happens. I would imagine at this moment in time, everything is just adjusting to get some new IP addresses. So we might just give it a moment. There we go. Okay, so as you can see, this is pushed over to 48 milliseconds there. That shows me that I'm now actually going out over the failover connection, the 4G one that I already set up there. So I'm just going to see whether in a moment we can go and sort out the other connections. So let's just refresh this page. We can actually just have a little look here and just see all our connections showing. All right, so we can see this is connected a little bit faster, obviously, because this is actually just going out to a 4G modem that's only got a 100 meg interface in it. So we can see that this is, I know this is physically connected. The port is up, but it's not actually working. So what we actually need to do here is we need to head on over to, let me just figure out how to do this. So we can see here that this is fully connected, but we don't actually have any information here for the connection. This is in fast Ethernet. That's what this color means. And this is a gig. That's because that's only connected to the 4G modem that we can see here. So what we need to do is we just need to hop on over to our Aussie Broadband page. And in our Aussie Broadband, we should be able to actually kick the session. So let me just see what we can do. All right, let's just have a see what we can do here. All right, so we're logging in to the connection that we have. All right. In here, there is some options to run self-tests. And what I actually want to do is kick the connection here. All right, by kicking the connection, like I said, this clears any config, any matching that they may have at their end between the previous MAC address of the other device I had in the UCG MACs, and allows this connection to actually then come back properly online. So as you can actually see, look, we can just see that's dropped very, very quickly down to 13 milliseconds from 50, probably just as I hit that button. So if we have a little look here now and probably refresh it, you can see there we've now got an IP address. So we are actually now switched over and functioning. Probably is going to take a little moment because it needs to call back on the other interface that was here. So I'm just going to give this a moment for it to catch itself back up again. There you go. But we are fully back online as we should do. So you can do a few things in here if you want to, and set up this one. As you can see, the primary internet is going to get a little bit better speeds than that. So we can actually set some options up to do some speed tests on here. So I might just tick the box here. When do you want it to be done? Daily, and let it do it at 3 o'clock in the morning. That will just run some speed tests, and then that we can use later on for if we want to do traffic management and stuff. At least it knows what the level is meant to be, so that it knows how to manage it. And if you were using this as a proper distributed here, then it's going to use that data to know how much it should, if you've got 10% over this way, 20 and 100% or 90% over the other way, sorry, a bit later and my brain's a bit fried there, then it at least knows what capacity is in each connection. All right, so a couple of things that we just need to do now so that I have everything as it should do. We will just need to have a look in our networks, and hopefully we've got 3 IP addresses picked up on here. All right, so one of these is probably going to be our firewall. I would imagine this has picked up the same IP address that it's had before. I don't actually believe the fact that that's a Windows PC. So let's just log in here. We can still see that our stats are updating on our WatchGuard that we've got here, and we can see that it actually has an IP. I'll just refresh this and make sure I had logged in correctly. There we go, 201's the IP. So we can use one of these features, which again is I showed you before, which is really great. So I'm just going to put this as WatchGuard T45. And I can fix that IP address like we saw before. So now that means that if this does refresh, this will actually always get that IP address. That's useful. Why? That's useful if we're going to do any port forwarding, or we're going to do NAT because we want to know that the internal IP address always remains the same. So I'm just going to quickly set up a NAT rule, or sorry, in this instance, a port forwarding, just to get us through tonight, so that I know everything is functioning as it should do. And then tomorrow I'll carry on this video, and hopefully we'll be able to start doing some of the other bits with NAT and everything else that goes along with it. So we're going to do this within side security, and we're going to do a port forward. So port forward all. Now I like trying to make any of the rules or anything I create in a firewall as useful as possible, because when you've come back 2 months later, 3 months later, and trying to figure out what on earth did I do there, it makes it a lot better. Now, in this instance, we've got 2 WANs. With the 4G connection I've got, I don't actually have a static IP address. So it's not necessarily worth doing both, but for completeness sake, I like to do this. Maybe if you've got two failover connections that both get static IPs from different ISPs, then this is a great way of making this port forward work, and that's to work for both of it. From is any. Now the ports, this is what you're going to forward the ports for. So if I get this right, it should be 1263. Oh my goodness, 63. Is it 65335? I think that might be it. We'll find out in a minute. Forward to what IP address? We wanted to forward it to the 172.20.21.201 IP address. That was the WAN, if you like, the public IP address there. It's not, but inside our network is the public IP address of the WatchGuard. Basically what we're doing is we're making the WatchGuard look as if it's at the front of the network. So anything that hits our public IP address will be forwarded directly to here. And so I think this we would just need to match up, and then protocols, you have both TCP and UDP, and we want set logging. And I think if I've got that absolutely correct and I've got the right derivation of ports, then that port forward is actually in place. How could I actually do this? Well, I actually like using a site called ping.eu. This is really good for just testing open ports and getting an idea of what actually is going on. It gives you an idea of what your IP address is. And then maybe I want to actually do a port check. And I happen to know that port 443 should actually be open, which is HTTPS. And so if I actually do this and my port forwarding is working, then I can see it is actually happening. And if I was to go to one of the websites on that, then it would respond also as well. So that shows me at the moment my port forwarding is up and running. And as a result, this is everything that it needs to be. And I've made the changeover at this moment in time, and I can then let the staff again back onto the network tomorrow. And then we can do some of the stuff with reporting and everything. But the great thing is we're going to actually start to see some of the traffic flowing through this already. And as that happens, and as you can see, here's some of the traffic already in here. And then if we were to use our insights and again our viewer, or in our inspection, as we start to look in SSL when we get to that stage, then we actually start to get and build up an idea of everything that's actually going through our network, and this starts to turn into being more than just a router. It becomes slightly more towards a cybersecurity device that gives us pattern recognition, that shows us quantifiable data, and allows us to do simple things to block applications that we might spot, or things along those sort of lines. So hopefully that's given you just an idea of how I've done this changeover, and then we'll work on some of those routing features tomorrow. Okay, so I'm back at my desk now. We've done the changeover. It's sat there for a few hours. I know that it's working. If we have a look in the dashboard, we can start to see some of this information starting to come together. It's interesting how a lot of this actually works. This is driven much more around application awareness than maybe logging every single packet and showing you errors in that packet. We will go through some of what you can see as we work through, but as you can see here, we can drill down. Now, most of the stuff is actually showing from the T45 because I've got a WatchGuard and then that goes to the LAN of the EFG. And out to the WAN as I'm slowly migrating, and part of this was to show you me moving those rules and seeing how we would set it up. So we're going to come back through and look at some of this as we go through security, but the first thing that we're going to start looking through is the whole area of routing and NAT, because this is an interesting area, an area that you're probably going to need to use the most of with port forwarding if you're going to put this in where a firewall was of some type. So if we start with routing and policy-based routes, policy-based routes are really useful in many ways, especially if you've got a multiple internet connections. So in our scenario, we have got 2 internet connections. Although I've got them used as failover, I can actually use policy-based to force traffic over one or the other. So if I had, slow download traffic, or I had plenty of bandwidth in one or a greater download allowance in another, I can use policy-based routes to give some level of control. So let me just show you, and let's simply set the scene on here. So if we on this computer here do a trace route to Google, it's going to go out through the test environment. It's going to go out through the Aussie broadband connection and out to the internet. So let's just let that run through. It slowly does its work through. While that's going, we're just going to go to my Linux test server here and just do the same thing of trace. It's not going to. There we go. Trace route. All right, and as you can see, I have followed the same path as this one has here. All right, so it has gone out, it has come back through. I think I can probably bring that window a bit more to the side, probably just make it look a little bit more even. But I've come out through Aussie Broadband. So what can I now do with a policy route? Well, I can now say, and this is where, again, Ubiquiti is based around already identified computers and networks, and so a lot of the setting up of many of these things are a lot easier and quick clicks, whereas often most of the traditional firewall vendors want you to actually physically create firewall hosts or policy objects for each thing that you want to do. So let me show you. So I'm going to create one. So as I said, I like writing things in fairly verbose because I can find my rules. So I want to redirect my test device, all right, that I can use. Again, that means wherever this travels around, even if this gains another IP address, because of its MAC address, and we've linked it and we named it earlier in the videos I was making, I can use this. We may have also decided to do this just for a specific VLAN. The interesting thing here is if you were doing this with a normal firewall vendor, you could potentially do this as a protocol as well. But you will see there are some options around some of this in a moment if you want to do it IP based, which sort of would help. So I'm just going to choose the test server here. I'm not doing inspection of HTTPS sites. So because I'm not doing inspection of HTTPS sites, I have an issue with maybe using a domain name at this moment in time, unless I knew it was only an HTTP. So in this instance, I'm going to choose an IP address, and I'm just going to put in here Google. I could have obviously put a port in here. So if I knew that it was destined from a specific port or destined to a specific port, I could have put there. So we could do some port redirection, maybe SMTP, if you wanted to send it a specific way. I need to remember to choose add to add this. And now the great thing here is I can choose which interface do I want it to go down. So I want it to go down that interface. Maybe if that fails, I want it to go back to the original interface. So that could be useful if you've got 2 connections, but one goes down, you want traffic to go back to the other. So you can use this in a number of ways. You can do this with domain names, a region, or IP address. So I'm just going to do this on IP address. So this is going to redirect my Linux server out. Now I do notice that it tends to rebuild. There we go. the rules, and when it rebuilds the rules, it kills a session off, which I totally understand, but you do get a momentary drop in the connection. So because obviously I'm using a remote session to make this work. So let's just do this same here, and actually now you can see completely different. I don't go out over Aussie Broadband, I go out over Telstra. If I now bring this back and do that same one here on my computer that's actually behind the WatchGuard, you'll actually see that I still go out through the Aussie Broadband connection. So I've now used a policy-based route to be able to redirect the traffic to a different connection. So that's a great feature that we see in here, and it's really easy to use. So compared with some of the other firewall vendors, and we do that comparison a bit later on, it's really easy to do. It maybe has some less control over it, because at the moment control here for source is more about an actual device or a network, not about a port or an application. Maybe that would be nice to have in there in due course. So we've had a look at static routes, well, policy-based routes there. I'm just going to remove this one so that as we go through I don't suddenly wonder why things don't work quite as they should do. So let me just remove that. Static routes are useful if you've got multiple routers or you're trying to do something very specific within inside it. If you know this, you probably know what this is. A destination network is going to go in here, so maybe you've got a subnet that hides behind another router that's part of an MPLS or part of an internal connection to another site. Then you can redirect it, and what's the next hop? Well, that needs to be another IP that is in the same range as one of the interfaces or one of the VLANs that the EFG sees. So that's what we see static routes for. OSPF, if you're using this to announce routes, then again you've got some functionality in here. I believe BGP at some point will be in here as well. So that's ways of, again, broadcasting networks that are dynamic and updating. What next one I want to look at here as we just work our way to NAT is DNS. This is really useful, especially if you've got maybe Active Directory or you have other internal servers. So we know that we've got a test server. Let me just see if we can rejoin, or we might just have to run it in this virtual environment just for a moment while this all catches up. Because it's just built the routes that I had on here. Actually, in fact, this isn't the one that I wanted. We've got this other test one here. So we can run this. Let's just see. Hang on a minute. Let's just get back to here. We can run this iperf test on an IP address 172.20.21.96. So if I was to, I'm just hoping my other server would start up here. Let me just have a look and see if I can get to it. If not, so let's just check that from this box here. We can ping, what do we have? 172, I think it was 172.20.21.144. So let's just check we can do this ping 172.20.21.144. All right, so we can ping this, which is what I wanted to show you. This we're just hitting as an IP address, but if our DNS server for our actual device in this device here is actually set up as the EFG, then what we can actually do is we can induce a DNS record for this IP address. And so we can now start to make it operate a bit more like a website. This might be useful if you've got an internal website and you want people to get to it because you've got it hidden behind your firewall, and it's got a public IP address and the routing doesn't always quite work. So what we can do in here is we can create this, and we're maybe going to just call this mytest.thetechgeeks.com. All right, and we're going to just put in that 172.20.21.144 IP address. Because my little test machine here actually has its DNS set of the EFG. If I now do ping mytest.thetechgeeks.com, this won't get passed out to Google's DNS servers to resolve it. The EFG will actually push the result to this device. And as you can see, we're now getting a ping from exactly the same device, but we've actually been able to give it a name. There's Sophos can do this. Most of the other vendors can't. It's just a little bit more messy, maybe because they haven't got inbuilt hard drives as well. But this is a really nice feature, especially if you've got references down the end of VPN tunnels, or you've got software already programmed to use a specific name, but you want to be able to get it to work and point to that name, even though it now is a different IP address. So that covers basically the way of inducing or introducing specific IP DNS entries into. So we can do all the same things as CNAMEs and forward domains. That's another really interesting one. So again, we can forward. So we can forward this to a different DNS server. Maybe we've got another Active Directory server that we want it to refer to, or something along those lines. So let's tidy this up. Like we've done before, all right, before we move on now. But hopefully that's a useful feature that you might be able to make use of. And let's move on now to NAT. So network address translation, the guts really of any router and firewall. This is where we gain control over what runs in our network, what we display publicly, and what's available from the public into our network. So there are many different ways and combinations of this. So network address translation, in its basic term, you will be using this without probably realizing it for some people in what is called a masquerade. So this is where we have many-to-one NAT. What is many-to-one NAT? This is where you have an internal network, 192.168.1.IP range, and as it egresses, so it travels from the LAN side of your router to the WAN side, this could just be for your normal ISP's router, it then picks up the external IP address of your router, and no longer does 192.168.1. appear in any of the references, so it's disguised, yeah? And that means now our network is private. So essentially, even in a basic router that we might get from a high street retailer, will have some level of protection in it, because traffic cannot get back into your network just because somebody knows your IP address, because the external IP address, that WAN IP address, has to be taught how to translate in. So we've got the many-to-one is one definition of it. We've got one-to-many, the opportunity to expand one IP address and spread it to many. This is often used in combination with port translation. So maybe internally you've got a web server and an email server. Email runs on port 25, web server runs on maybe port ATM 443. You can have one external IP address and translate that to two different internal IP addresses. Sometimes that's called PNAT. We also got DNAT for destination NAT, source NAT for source NAT. So we can do some clever things. If we can see what port a packet was coming from, we can rewrite it to a different one if we knew what a destination port. So maybe you have got multiple web servers or multiple devices in your network that all run on port 443, and you want to access them all remotely. Then unfortunately you can only direct port 443 to one of those devices, but you could, using destination NAT, you could destine anybody for port, say 444, to go to a specific internal IP address and match it to port 443. And then somebody who came to port 445 could be redirected to another internal IP address still on port 443. So the key here is we have to have a unique port per IP address. So I think we've got whatever it is, 65,300 and something odd of them. All right, but you can't reuse them in your network. So if you're trying to get access into your network, each port reference has to be unique, or you need to have multiple IP addresses. So what I'm going to do first is I'm just going to show you how we can add extra IP addresses that maybe our ISP has given us. Remember, we had covered this in our internet. We've only got a single IP address given to us via DHCP here. All right, but we have also been given a batch of IP addresses from Aussie Broadband to use. So we're just going to set up a very simple test here. Just to show you how this actually works. So we're going to use destination NAT because we want to create a rule that comes towards the WAN, the exterior interface of our EFG, and then is translated to an internal server. And you want to be careful of these rules. If you get this type of thing incorrect, then that's where your firewalling starts to fall apart. And I'll show you as we go through. So I like to make this really nice and clear. So I'm going to set up a NAT rule, and basically, so you could do some of this in port forwarding. Port forwarding is a little bit more cumbersome when you have multiple internal servers across your network, because you end up having to exclude some addresses or some ports from some of the port forwards. I have lots of different port forwards. I much prefer doing this in NAT. I feel it gives me a greater level of control. When you're normally using a firewall, or one of the mainstream firewall vendors, you will create a NAT rule which will link your public IP address to your internal IP address, and then you'll have a firewall rule that runs over the top. We'll have a look at some of those firewall rules in a little bit, and a way to do some of that as well. But in a basic sense, we can control it in this way. So I'm going to set up a rule for ping for this IP address. So if we use our favorite tool out here, ping, and just try this, let's just try and see if this will actually give us anything. And it shouldn't do, because that IP address has not been bound to our EFG. So in a moment that will time out. There we go, no response. So we're going to write this rule protocol. What do we want? And we've got a whole lot of protocols in here, and this is, you want to be as careful as possible, and this is where you want to know what ports. If you're choosing TCP, UDP, you want to be very definite about the ports that you're going to do. You don't want to ever put all of the ports in here, otherwise you're essentially opening that entire device to the internet, which you might be wanting to do, but it obviously then will rely on its own firewalling. So in this instance, we are only wanting to push ICMP, which is ping. So I want to choose a ping. I'm going to choose the LAN interface it's going to be on. Now in destination, what we're going to now do is we're going to add in our IP address. Now it's possible we might be able to add this as a group that can be referred to later on, but we'll come back. So in the basic term, we can choose it this way round. I don't need an opposite match. Now you can create an opposite match. So that would mean that this machine, when we're going to put its internal IP address down here, when it went out to the internet, that was the IP address that it picked up. So this is often useful if you maybe getting a specific for email, SMTP, that you get a reverse NAT that matches, and then that means that when the connecting SMTP server actually does a lookup on your IP address, it matches the entry correctly with whatever DNS you've set for that public IP address. Destination port, it isn't really relevant in this instance because this is ICMP. All right, source, so we could link this so that this was only going to action if it came from one specific IP address or range of IP addresses, so we can put that in there. That might be useful internally if you were doing something, but we'll look sort of similar in firewall rules in a minute. So let's put this in here, and I think it is on 197, I believe, is the IP address. I could now translate the port because it's matching you would need to set these up over on this way to make this work, and it's not going to work with ICMP because ICMP isn't a port-based scenario. So as you can see, if I change that now, I could match it up. So this is where I could have a destination port of, say, 4443. Maybe see if we can show you this in a moment of actually how we can translate it. So let's just do it this way round. This is the IP it's going to relate to. And as you can see here, I've got some options if I want to exclude this. So you want to exclude it from the NAT and want to send this out to remote logging, which is set up in your settings if you've got an off-box syslog server. So I've now created this destination rule. I'm going to put this back to ICMP. So in our rule, as you can see, we're going to hit this second IP address that we have for Aussie Broadband, and then we're going to translate it to this internal machine. So we've now created that. You can see this reference here. So if we come back up here, and now actually run this, hopefully all being well, we should actually get a nice little response back from this device. No, we didn't. So maybe we just try it again. It's possible that I actually put in the wrong IP address. So let's just give it a moment to have rerun that. But then we just probably, while it's doing it, going to need to just check that I did pick up the right IP address for our test server. Oh look, 196, my bad, so that's not going to work. So here we go, we can come back and edit our rule. We're just going to change this to be 196 and apply it again. Attention to detail is what always catches out, and you need to keep coming back to that. So now if we do apply on here, there we go, there's our ping. So we can actually see that this works. If you want to satisfy maybe some more of your curiosity around this, then maybe just make sure, we know this, I know this responds on a web port, so let's just make sure that my NAT rule hasn't got a little overexcited and now exposed that machine to something else, and you can see that's closed. Right, so let's build on what we've done here. I've created that NAT rule for ping. What if I now actually want to open that for specific traffic? So let's follow that same scenario again. So let's put our IP address in here, WAN 1, and I'm going to call this HTTPS. All right, I will leave that as that for the moment. I'll show you a bit more. So we need to have this as TCP because that's what HTTPS is. So it's coming into the primary WAN here, which is fine. Sorry, we're doing this on masquerade. We don't want masquerade. We need it to be in here. Destination. Again, we're going to put in our IP address that we need here. Port destination. So in this instance, we want to send this to port 443, which is HTTPS. And again, into our 192.20.21.196. Let's get that right. So we are now not doing any translation, but we have written a rule that is basically just going to allow 443. So now I've accessed my web server. Let's try and see if we do SZJ. Right, I think I've just put that in wrong. Right. The port is open. So that now has enabled us to have a web server open to the internet on port 443. What if we wanted to now actually change that around slightly? So I'm going to have this as destined for port 4444. Internally, I still want my machine to respond on port 443. So let's apply those changes. So now let's try and get to port 443. And this will be completely hidden. Right, the port is closed. Remember, my internal server is still running on port 443. What I'm actually doing is hiding this or changing its port. This allows us to do quite a lot of things when we've got multiple internal firewalls, or we've got other devices that share similar ports. So that has given us a good step through of what we can actually use NAT for. And hopefully it's shown you how to also add secondary IP addresses when you have DHCP for your ISP. So hopefully now you've seen how the basics of NAT can be used to work as a basic firewall rule as well when we're doing port direction and all of those bits that relate to it. So let's now start moving on to how some of the security works together first, but we will actually just have a little look at IP groups because IP groups can be useful in here. So some of the rules that we create will allow us to use multiple ports as we go through this that we can now group together. So for instance, we might have, we might call this web server default ports. All right, and in my port group, I have 443 and port 80. I now don't have to keep coming back and adding those in each time. I've now got a nice little set of server port groups created in there. I also have options in here to create an IP for address. So maybe I can put this as this, and maybe at some point we might be able to use this as we go through. So I'm just going to quickly go back and just see. I can't remember where in all the places you can actually use this, but if we go back to our NAT rules here, and let's just actually see, I don't think in here it allowed us to use, no, it didn't allow us to use any port groups in there, which is a bit of a shame, because that would have been a nice way to start being able to reuse some of this. So that is a difference between some of the firewall vendors at the moment. Of how that actually works. Again, it would have been really nice to have these as objects that had been defined, because we're going to keep using these over and over again. But we will use some of those port groups, especially when we get into firewall rules. So let's start here with the general tab. So device identification, this is what we've already seen in the dashboard. Essentially, when we look in the see all and we can see which computers they're coming from, this is the identification portion that's working on that. If you don't want that type of thing happening, then you can take that out, but I would suggest you keep it there. Again, here with the type of traffic that you've got running through it, again, we see that here in our dashboard. We've got, you know, everything split out for that's recognized as applications. Adobe, Stun, which is, you know, an update often used in VoIP. We can see SharePoint's running in there, Microsoft Teams. We can see other ExpressVPN. We can see other almost everything that we know here in ways that is running in the background is notified as an app. And in that basic term, with this in here, we can immediately create block rules as well. And we'll have a little look at those rules as we progress through. But it's a really simple, quick way of going, I don't want that to be happening, and be able to kill it off. So we need that really to be set here. Country restrictions. So if you want to set up which countries have access or you don't have. Now, be very careful with this. Not every country IP ranges are totally locked correctly in each country or state. And you might want to, this is probably, again, if you're going to use this because you've got inbound firewall rules, then you might want to use it on incoming. Probably a lot of people don't necessarily use it on outgoing because, again, there's applications running all over the place asking for information from many different data centers. So it might be something that you need to trial if it's something you're interested in. Ad blocking. You can apply this to a certain number of VLANs. This will take out domains that are known for ad blocking, and you will get blanks on some of the pages. Might be something that's worthwhile looking at for you, but again, play with it. DNS shield. This is an interesting one. So this whole idea of can we inject records? As you can see, I was injecting records earlier. What if somebody upstream was injecting records as well? So we can move this to DNS Shield and move this to auto, and this will actually use Cloudflare and Google's servers, but we'll send the data of the request encrypted, and that again will give an extra level of protection for your network. So it's something, again, you might want to play with. It's obviously not going to work if you've got internal Active Directory servers that are doing DNS anyway. Create a honeypot. If you've got an inbound IP address, then you maybe want to, you can fix that up so that it's collecting a pool of information. Whether you use that or not, that's up to you. Okay, so we're now going to move on to intrusion prevention, and this is where it starts to get a bit more interesting. We did some speed tests earlier with this in the video, so you can see it really, in our test environment, didn't take any hit on it, and I do think this was probably going to be doing 6 or 7 gigabits a second easily with this running on, as you can see. So what is intrusion prevention and detection? These are malicious things that may happen through your network, through requests that you're making, through applications that are doing things that shouldn't. this is not protecting your individual PC. This is protecting the data as it travels through your firewall or back from your firewall to a device. So if you're out and about, it's not going to give you protection, and it's only going to give you protection for information that is traveling through that device. Like I said, if you get a virus or you get some malware onto your local machine and that goes to another machine, this is not going to help you because that traffic is not traveling out through to the internet. If it is a command and control center based bot type of thing, then it will probably pick up those as signatures because they're trying to call home and will maybe be able to block some of that traffic. So we're here in Australia, and at the moment the data center side of things for us hasn't been set up for Ubiquiti, so we can't really test the enhanced protection of this. What this gives is this gives you more regularly updated threats. This gives you a larger signature base to check against. It's going to be probably $100 a month, somewhere along that, which is something to consider. It will really depend on how much you are doing with IPS. A lot of what we do is with content filtering and application control now, but IPS is something there as a significant tool to sniff out things that shouldn't be running in your network. So I can't test that bit, but do know that the signature bases will be better, and more regular updates will give you some advantage for generating or newly created threats that then have signatures made from them. There is often a time from that to the signature being made, and it's not going to stop what we call zero-day threats. Zero-day threats are things where their signature doesn't match it at this moment in time, which is why we start to look for stuff in SSL. So I'm going to use auto. Intrusion prevention should be able to be enabled across your whole network. It's up to you how you set this off. I would suggest you do it in notify first. So this is going to start appearing in your insights view for things that are untoward. And I would probably suggest that you start as a high, let's have a look, medium sensitivity. You probably want to get to high if you can, or you can customize this. So you do have some options in here, not a lot, but you can see what we've got. So we've got a bot. So this is command and control bot that I was talking about earlier, malware, mobile malware, trojans, and worms. So stuff that might have been installed in something you downloaded, it's going to stop that. If you don't think you should have any peer-to-peer traffic traveling through your network, then again, you can put this on, especially notify. Why not turn these on for notify and actually see what's running through your network? Hacking, denial of service, exploits, these are probably, maybe we want to see what's happening with games and any other clients and things that we can see happening. At least in our instance, we're only notifying. So we're going to see some notification or logging of what's going on, and we can decide whether those should be allowed, because we can actually put all of this on and then allow specific things through. And that might be another way of doing it. Advanced protocol, all right, do we want to see things that maybe are malicious happening? Other potential. That's always a dangerous one because we don't have granularity in here, and many of the other firewall vendors have a lot more granularity. We're sort of trusting what this is going to see in here. I like to see SMTP because all of my stuff is in Microsoft 365, so I shouldn't actually be seeing any SMTP traffic. That was going to be an indicator that maybe something has been compromised inside my network. So I'm going to save those. That's going to be monitoring. So dark web blocker, immediately going to be block stuff that is encrypted by Tor, so it can't be inspected. Known malicious IPs. These are things that you would be expecting to be updated more regularly if you had a subscription service, because these are changing all of the time. You can now put in here a detect list. So you can say, actually, in fact, these devices aren't going to fit into this. There could be some things that will get picked up potentially as being an intrusion, but actually aren't, just by the way the packet's formatted, but you don't want to take it off for everybody. So now, as you can see in here, you can maybe have a source, so you could choose which IP address in your network is allowed to avoid this set of checking. So this is actually really useful to make this a usable set. So I'm just going to apply that now, and that's put that on as a function now for our network and is set up. So like I said, eventually you'll probably want it to have a notify and block, so it'll say this was blocked, but to start with, bring it in as notify. I've chosen customize because I'm on notify, but I'm aware that if I do go and put this to block, I may have a bunch of categories, especially this one, other potential threats. That's almost saying you might be caught if you're going speeding. You may be not. It's a sort of bit of a hit and miss. I would stick this still on notify for a little bit till you can collect some information, and we're going to start to see that appear in many of our detections and everything that's going along with inside inspection as we start to roll along some of our SSL encryption and anything else here we can see in our intrusion side of things. So we can see no inspections will be logged because nothing has been detected at this moment in time. So we can start to build up a list, and we will see that when we see clients in here, and we will see some of that information build up in a useful level as we do that. Now, what I do find is that as we make some of these changes, I often notice that we lose some of the information about it. I don't know whether that's because I'm being not intentional about it, but I do find that some of the bits and pieces don't always, or they do seem to clear. Certainly when we changed the WAN connection, we lost a lot of historical data in here, because if you see for the video yesterday, I had quite a lot of early inspection information that's now disappeared. So I have done a couple of factory firmware updates, so that may have also cleared some of the logging information as well. So let's just bring ourselves to back where we were into intrusion prevention, and that hopefully covers really how that works. There's not a lot of control there, but probably enough to give you a peaceful night's sleep, knowing you've done probably what you can as a level of protection for malware and software that's been installed that's maybe got Trojans installed on it. Like I said, it's only going to protect traffic that's traveling through your network. You can't really do this on its own as a firewall for any vendor really without some sort of antivirus or anti-malware product running on each device as well. So let's just have a look at port forwarding. We set up this essentially a forward all rule. Now, we could have done this as a NAT rule if we wanted to. Which would have been another way of doing this. We would have gone back into here. We could have created a destination, and we could have done all protocol interface that it was going to arrive on. Destination was the public IP address there, and not set anything else in place along here, just the internal IP address that we were going to use in that instance, which would have been the WatchGuard. So that would have been another way of doing it. I find that we get a little bit more granular control when we are doing things with NAT than port forwarding. But as you can see, it's fairly straightforward. In this instance, as you can see, we only have a definition for WAN or which WAN, whereas in NAT we can actually put physical IP addresses in, so we were able to add those extra IP addresses we had on our Aussie broadband. We can choose limited source if we wanted to. We can choose the port that is destined for. And we can then obviously our forward IP and our forward port to it. And this again, you see, only has TCP and UDP. So port forwarding in this instance isn't going to work if we were trying to do something with ping or some of the other protocols that were in there. So it is a feature. It did what we needed it to do at that moment in time that you can see here. But probably that rule could have been changed around if we'd wanted to. So I see port forwarding as a easy, simple, if you only need a couple of ports forwarded, this will probably work beautifully well for you. Beyond that, I would suggest that you probably get to use NAT, and as we'll look at some of these traffic and firewall rules as well, those two combined together will probably give you a greater return. It may be a little bit more time consuming to set up, but it will operate a bit more like a firewall would in this respect. Okay, so let's work through traffic and firewall rules, and this starts to cross over into everything that we've done before, which is port forwarding and NAT. And you'll end up using a combination of these to be whatever you need to work out in your scenario. So you'll actually see these run in an order. And so if we look at the internet in, these are the interesting ones for me. This is always to make sure that we don't have anything inbound that shouldn't be inbound. All right, so we're allowing established related traffic, internet in for the protocols, but it has nowhere to go. So as long as that fits in the valid side of things, that are a reply. So this is, again, we've made a request from our LAN out to a website or whatever, and this is the return journey is allowed through. What are we doing? We are blocking all the packets that start out on the internet and that are not relevant or are malformed. This one down here, if it doesn't match, then we're basically blocking everything. You'll see our port forward is then further down the list, and our DNAT rules, our destination NAT rules that we created, are here. Now, with inside here, we can actually do a little bit more based around what we did with profiles and these IP groups. I'll just get rid of this test one that I put in here for a minute ago. I was just trying to see whether something was in here that would have been really, really good. So for most stuff, if you're not having to do a rewrite of the port or the destination or even the source, then probably a lot of what you're going to do is here in Firewall Rules. So we're just going to rewrite these ping or this these rules here, this HTTP rule. So we're just going to rewrite this as a firewall rule. We can't do a rewrite of the port and change the port number, which I think is what this rule had from memory, because in our NAT, when we were in our NAT and we created this one, as you can see, we had the source, or it was destined for port 443, but we're going to, sorry, it was destined for port 4444, but we rewrote it to 443. So what we are going to do here is we can't actually translate that bit, so you'd need a NAT rule to still be able to do that. But we're going to do this as an advanced, and I'll show you the simple ones, which has got some really good features in a moment. So type is our internet in, so we can allow. So I like to again use up a HTTPS in allow. Now I'm going to actually just make this more web server in allow, which I'll show you in a minute. So we've got the options to accept, reject, and drop. We can choose our protocol. We're going to allow. I'm not going to allow all. Mine are just TCP. Opposite match. Don't need to I'm not really worried about that. Source, I don't care where it comes from because this is making it as a public server. The destination port group. All right, so now in here, where are we wanting this to go to? Well, the great thing is we were actually able to have chosen this earlier. And because in profiles we created our IP in this way round of doing it, not in the NAT rules, but here, we're actually able to add this in. We can create new ones if we want to. Now, the great thing also here is port groups. So I actually created a port group called Web Server Default Ports. I think I showed you that earlier. I'll just go back and do that in a moment. So I can now actually put my ports in there. If this at the moment doesn't allow multiple groups, which is what I was trying, which would have been really nice to be able to select multiple groups. So what I would do, which with other vendors that allow it only in this same way, would be to have this called this port group. So let's just go back and let me just show you what I mean. In profiles here and IP groups, we've got this one called Web Server Defaults. I would have actually probably called this default ports, and then I would have had my ports in there. That allows me to find it easily and I know what I'm referring to. So in security, I can now do traffic rules. I can now do my create as we were doing before. Maybe we're just going to in allow ports. All right. So we've got that as allow. Our port group that said for the source we didn't worry about. For destination, we want it to be space to go into here. Port group now, we can have our default port groups. In manual, you have a little bit of information you can do. Again, you can do logging in here when this is matched. So we want to create a syslog. If you've got an external logging system that's going to match and be useful, then that might be useful to you. So I've now created my rule, and as you can see, it actually appears there right at the top. And it shows me what it's actually written and the ports that it's written for. So all being well, I can actually probably remove these two. So I'm going to go back to routing here and NAT and find those couple of rules that we created in here. And we should now actually be able to choose manage and delete. Well, I'm going to delete this one because I'll keep my ping one there. So hopefully if I've done this correctly, now I should be able to again look in our firewall rules here. It's right at the top of the list. I do have the option to realign these, so when you create more, it's going to go down, and as you can see, the bottom one here is a catch-all and block everything that doesn't match. So it matches as it goes down. So obviously if you had another rule that was redirecting a specific port, you might want to have that higher up the list. So let's go and have a little look and just see if our port, remember it's now our port 443 is open. Maybe I didn't get that right. No idea. Let's just quickly refresh the page because I can't read that. All right. All right, and so we should get a port open, I would hope. No, port is closed. Look at that. So that is not actually responding to a port open, which I find is very, very interesting. So let's have a little look at our firewall rules in here. And it is possible now that my NAT rule is actually needed because I no longer have that IP address defined in there. So let's just have a little look and just go, well, we can do the ping, and let's go back and try ping in here. All right, so let's just all right, so we get a ping and we know that that works. So let's go and have a little look and let's run back into here for NAT. So we can do it this way, and this is something that could be worthwhile having a look at. So destination, so I'm just going to call it this WAN 1. So what I'm interested in, all protocols, the interface is there, the destination is actually going to be this IP address. Now, interestingly enough, I wonder whether I need to actually translate it or whether it will allow me now. So we do need to translate it. So for this to work, by the looks of it, I'm going to actually have to use a combination of the firewall rules and this to make it work. So 172.20.21.196 we said it was. So I'm not translating any ports, and I've basically essentially created a NAT rule that in many ways is completely all. So it's quite dangerous on its own, but it should be that our firewall rules will be above it. And so even though it might be in here, interestingly enough, our DNAT rule is still in here. And I hadn't expected that one to be in here. Let's just go back into our NAT rules, because I thought I'd actually create this. Oh, I've added no destination. So here it is. So let's just try and work out here what's going on, learning as we go. So let's maybe, I've just not updated, let's just see if this will refresh itself, and I've just missed something along this step here. All right, so this has updated itself. So you can see that this is lower down. So we've actually done a straight NAT translation. If this firewall wasn't in place, I would expect every port, every protocol to be available here. So let's now try our port check again. And we can do 443. All right, and we can do JFDU. So our port translation actually works. Now, at the moment, we can ping the device, I'm pretty sure. So let's just see. we should get a response, which we have. So what we want to do is we can see in here this ping. What would have been lovely in here would be a pause or a disable the rule option instead of potentially deleting it. So I'm going to come back here and I can see this ping rule that's in here. I'm actually going to remove this. And theoretically, by removing this from here, when we come back into security, and we saw before this hadn't always updated, so let's refresh this page. I would expect ping not to work because the only allowed ports here for this NAT are actually up here. This one though is explicit and basically allows all protocols and everything in. So my hope would be that if we actually do this again, ping is allowed, which that to me means that NAT is happening before firewall rules. So that is a little bit more concerning in how I'd expect this to be done. So let me just have a quick look and see whether we can figure out a way of making this a little bit more restrictive, because that means realistically on our NAT. So I think this is probably either my interpretation, and I'm sure many people will correct me, or it's just the inception of how this is currently happening, because I would have expected up here the only in ports that are allowed were ports here, 443 and 80, and anything else would be blocked. But because NAT is happening before, and this NAT is evidently in the background happening before the firewall rules, that's why it's actually allowing that to happen. So if we go back to our NAT here, and this is allowing everything through at this moment in time, then we do have a little bit more of an issue, because we're going to end up with a whole bunch of NAT rules. And sometimes you won't need a NAT rule if you are, as I showed you before, just using the WAN interface of the firewall. We're doing this because we've got this other IP in here. So in this instance, we would now need to restrict this down to being TCP. And it suggests that everything is being forwarded in. Which means that in here that I'm going to need to put in here the different ports that I want to be allowed as well. So it's a port range, which is going to be a little bit more annoying. So 3, it looks like it's going to only do one port at a time. So if we come back here and do a ping, I would expect this ping to now fail, because we've removed the NAT rule, or we've made the NAT rule very specific. There you go. So it's failed. So at this juncture, and how I've worked this out, might be completely wrong, is that you're going to need to create multiple NAT rules where you're doing translations and where you've got other specific IP addresses in place. And it looks like that NAT is processed above a firewall rule, and that a firewall rule then doesn't take precedence over the top of it. Normally I would put a NAT in place and then have a firewall run over the top of it. This firewall rule technically in here should only be allowing these default ports to actually happen. It might be, no, it's fine, because it's only destined to those ports. The protocol is all, which doesn't really matter. Maybe it's catching it because of that. So let's just go back and change this to TCP IP. Maybe that is allowing it through. So let's just go and follow this theory through. So the theory through is that we need to make sure that this didn't have anything like ICMP in there, which is what all would have expected, because ICMP wouldn't have picked up a port group, although I'm not totally convinced about this. Let's just go back into here and let's just take off this destination port. So if my theory is correct, or what I've just tried now, this probably will ping. So let's have a little look Maybe it won't. So it hasn't. All right, so let's just try that again. All right, so we can be explicit in our protocols, and that can then restrict how much or how the firewall rule works. So let's just run that through. So we have got a NAT rule here that is natting a specific public IP address to a specific internal IP address. It's not translating any ports. You're still going to need this if you need port translation that we showed earlier. We've then got a firewall rule, and that firewall rule needs to be very specific about just being TCP IP. Just because I had it only for those destination ports, I was hoping that it was going, well, that packet is it destined for those ports? And it basically went, well, actually the protocol trumps the ports, and because it was destined for ICMP and ICMP doesn't have a destination port, this didn't actually come into play. So now we've created a firewall rule that should just allow port 80 and port 443. So we'll just have a little try. I can't remember whether the server will respond on port 80, but let's just have a little go and see whether it does. All right, and it's open. So those port groups are working correctly and neatly. So NAT does trump it. Well, no, the firewall rule is taking precedence after NAT has happened, but what we're actually seeing is that you need to be very clever on the protocol. Don't just rely on the destination port. So as you can see, it can be very easy to get this to a point where things are open on the firewall that you don't want them to be. So some people will be just doing port forwarding. It's maybe one of the safest things that you want to do, but if you want to do a little bit more in depth, hopefully that's shown you a little bit more around how this bit works. So now let's look at some of the greater things that you have in a device like this when it knows about applications. So we can create simple rules. So remember in our dashboard, we can actually see the traffic type that's flowing through here. We could just find one of these and we could simply and easily block it. So let's just come along here and say, well, let's block Groupon. So it's saying, what do you want to do? It's creating a simple rule for an app Groupon. And that is simply it. We can select a network. So maybe we just want it to appear on VLAN 37. Save that, and we can just call this block Groupon as an application. It's not a website, as an application. We should now be able to see in all of our rules here, block Groupon is at the top. That was simple and easy to do. So you see something on your network that you're not happy about, then you can easily block it. And you can, obviously, as you can see, what we did there, let me just show you, is obviously we can select this, which is the beauty of what I like going on here, is that because it's driven by knowing the devices on your network already, then we've got this option to actually just pick physical devices and block it just for physical devices, obviously that MAC address or specific segments. And it's super simple. You don't see this in many other firewall vendors of how simple this approach is. Let's just have a look, because we'll have speed limit there as well. So I'm just going to delete this rule and then actually just show you us creating one of these from scratch. So let's create this rule. The way to do this is going to be onto simple. So let's just call this simple app block. My suggestion would be let's base it on Groupon again, because it has low risk. Groupon app block. Again, I like to name this so I can find it. We're going to block it. We do have the option here to rate limit if you want to speed limit this. So maybe you're in a school or you're in somewhere where you're sharing the internet. Then obviously you could put rate limits on this. You could maybe stop YouTube going more than 100 megasecond if you had a several hundred second internet connection. You wanted to reduce its speed. So that it didn't saturate your network. So on the block, we then have we have a number of simple options in here. This is where we can do simple blocks by region, subnet, but those you should be able to do. Again, this would be, you could do a block or allow. So when we look at content filtering in a minute, if it wasn't blocking enough websites, then you could actually add something in here to a block or allow, or maybe it's blocking a site that you don't want it to. So what have we got? We've got two options. We've got app and we've got app group. So app group, if we choose app group, well, let's just choose a source first. Again, let's just put it onto VLAN 37 because that's less risk for what's going on. Maybe we can have a speed limit in here. later on. And again, you can do profiles of time. We can do setup schedules of that, which is really good. Your app groups, this is really where things are set in. So we could do games, VoIP services, web services. Many firewall vendors will have a lot more categories than this. And I'm sure that in due course, maybe we'll see that come, but that often comes related to subscriptions. So peer-to-peer networks. Maybe we want to just block peer-to-peer or business tools or proxying tools, social networks. That's your choice. But we're just going to concentrate on apps. And now we're going to select it. And so, or if it understands that app, it will be found in there. So again, if you find things on your network that maybe a team member or is happening, but is consuming bandwidth, then you can obviously do that directly from the dashboard, you can see, or you can create this rule from here. So in this instance, we've now created it for VLAN 37. Our app block is at the top. If we would try and go in, that application being used in the background is being blocked. That will mean the user will probably not know anything other than it's not working. So that is something probably just to consider when you actually look at that. Because it's an application, it's not being presented with a web page or anything else like that, the user will generally not get a this is not working. They will just come to you and go, the app doesn't work. It's a good way of routing out in your network things that maybe you want to block. So there we go, we've got that in there. Let's quickly just touch on the content filtering before we go on to the last, which is the main section of this, is the next AI side of things. So as a device, this has a certain options on content filtering. We're going to see much more of that with inside Next AI, because once we've got Next AI going, then we can see inside HTTPS traffic. Content filtering for this happens at a network level, so it can happen on a specific VLAN, for instance, or your main network. You will have seen you've got these three options on here. This can only intercept what happens before the encryption happens. So this is going to be reading the header before the HTTPS portion of the encryption happens. You can't really get any control over this. So this is a big difference to a lot of the firewall vendors, where you can actually choose all the different categories that you want to be blocked. We can use our filtering that which I've just showed you for our firewall rules to allow websites or to block websites, but we don't get a category list. Traditionally, those category lists are again in subscription, so we may see that in due course. So as you can see in here, if we choose a work policy, that's going to block out a large percentage of the things that we want. What if you've not been aware of what safe mode is? Safe mode is an option that you can turn on in a web browser. So if we were looking for a word XXX, what we can do when we turn on safe mode is it actually takes out the content. So it doesn't just stop you clicking on the link later on and blocking the website. It actually removes that content. Now that is using the searching capability filtering that is built into your search engine automatic. So it's just enabling that on the fly. But it is a great tool to have for work and family. You can see on here that family blocks a little bit more. It blocks VPNs as well. So you could choose to use that. We'd probably use the work one most of the time, and that's a great starting point. What you then want to do is use that in combination with your firewall rules here. And obviously we did this before. We can do a simple rule, and what did we want to allow? And we could show you again, this source was from a certain network, and what did we want to do? And we could say, well, we wanted to actually allow a domain name, and now we can put in the techgeeks.com or something like that, and that is now our added domain. So we could create up, if you like, our own block list. So it has some basis. I would suggest that most people are going to use the work or the home one as a starting point, and it's going to build from there. And then you would add in some manual lists. I hope in due course that we'll see a bigger, wide signature list for content filtering to choose from. But there is at least a start of ones there. So let's move back to security, and now we're going to hit on probably one of the bigger subjects on here is Next AI, and try and work out how to get this working and demonstrate that on our network. Okay, so before we head into Next AI, I just want to show you some of the data that has actually already started to be collected as a result of all of the changes that we've made so far. So we can actually, obviously we knew all of the traffic that was going on in here already, but we can now start to use our inspection side of things. So if we now use intrusion, because we were monitoring actually everything, we can actually start to now see, and we can actually go, well, was anything blocked? No, because it's all allowed. Does anything fit into any of these specific categories? Yes, some of these do. Let's just have a little look. I think allowed, if we take that off, okay, so that won't work. So we can start to see some of these. Let's see if there's any high ones. There's no high ones, so we know it's just medium. So again, we can start to see a build-up of what traffic is going through. Now, like I said, this is all going to show as my WatchGuard at the moment because the LAN network hasn't been moved to it. Once that's moved to it, then these will show as individual machines, and I'll see what's generating some of this information. And this is super simple to manage as well. So now, obviously, I can see this that's come up. I can see some of the information. I can see where it's actually trying to go. I can see some information, and I can now just immediately choose these options. Do I want to exclude the source IP address so that it no longer is analyzed for this traffic? Maybe I want to allow this signature through, so that would be great. Like we've said, we've set it to actually block, and now it's shown as block, but we want to allow it. Do we want to block the connection altogether? So we have some simple, easy control over this. So I thought it'd be useful to show you that. And we're going to now start to build on this because we need to see this happen now as we go along when we look at what we can do with inspection. So let's head on over to NextXI and let me just start to just talk you through a little bit of this. So as we know, around about 80% or more of websites around the world are now encrypted using HTTPS. So the connection is made from my local machine to that web server. It essentially creates a basic VPN. And so other than reading the start of the packet header and being able to see that it went to facebook.com, for example, once that has happened, I can no longer see what's in there. I can no longer tell if you're clicking a link. I can no longer tell if there was malware inside there, downloading something that was potentially compromised. So really, we want to be able to have a look inside that. Now, the only way we can do that is what is called a man-in-the-middle attack. All right. There is an acronym for it. You can probably work that out, but my dyslexia will get them all muddled up, so let's not worry about that. So man-in-the-middle attack means this. What we're going to do is we're going to interject a firewall, or in this instance, our EFG, and our EFG is going to intercept the traffic. The only way it's going to be able to intercept that traffic is by breaking the HTTPS tunnel. Now, when we break that HTTPS tunnel, we can now see inside it, and then the firewall can look at the other traffic that's going on. But that doesn't give a great experience for the user that is actually going to be going to a website. So let's step this through as we go along. So our first point in this is we are going to turn this to simple mode because that's probably the easiest way to actually get this functioning. This is going to be your main item that you need. This is your SSL certificate. Now, some of the other vendors have a portal that you can go to, which makes it a little bit easier for your users. They can go to the IP address of the firewall colon a certain port number and download this. This needs to be installed on everything. So our first point of call and our issue that we're going to have is that we don't want this to be put, or can't put this often in some Internet of Things. For instance, you can't put this certificate on a smart light bulb. So that means if it's using HTTPS to call back to its control system, it will stop being able to connect to the internet. So there are some things to think around there. This is quite an invasive, doesn't matter which firewall vendor you do it, there is no way around this. This is an invasive step. All right, so you want to think very carefully about what it is. And this probably drives us to a bit of segmentation. It is a little bit short in its comings here, where before we would be able to write rules around it. I'm pretty sure that if for other vendors, for instance, we'd be able to create a internet out rule. So if we check and do an internet out rule, that we might be able to avoid the Let's have a look. Source port group, destination. So you might be able to get round it if it was, and you actually created a specific port group for maybe 443, and then into this source group or IP address, you actually had to put in the IP addresses of all of the devices that you wanted to stop, or you create an address group here. Let's just see if that allows us to do it, whether we can create an address group. So the address group actually has to be physical IP addresses. So this probably is a slight shortfalling for me in where the EFG is at the moment. And somebody else go, oh, I can do it this way around. Great, help me. We can grow this and learn this together. But generally, most of the mainstream firewall vendors have ways of blocking out specific IPs, so they aren't enforced from this. We can choose specific, but it's all networks, but it is all generally based around a VLAN at the moment. So you might want to think about separating your Internet of Things out onto different VLANs if you weren't going to enforce this. So I'm just going to put this onto VLAN 37, all traffic types. So this will only inspect these 4 protocols. There are other vendors out there that do everything. So as if it's encrypted, they'll look inside it. This follows more of the Fortinet model where we're just doing specific known protocols. And that does affect performance, and it does increase performance. Inspected domains, we're inspecting all of them, but for instance, if you were doing this in a corporate environment, you might want to take away NAB or Combank or someone else like that, so you're actually not looking at the content inside there. Otherwise, potentially, you can see some of the actual information with inside there of credit card details or login details that you maybe shouldn't be keeping. At this point, what do you want to do? You can just track it. This is for extra actions within inside this. So we've got options here for queries, which I'll show you how it works in a minute. But at the moment, we're not doing any extra actions. We just want this to work. Insecure certificate, you could put high risk. Untrusted certificate, there's a lot of those out there, so you might not want to choose that. So this is our starting point. Like I said, you will need to have downloaded this certificate. Let's just hop on over quickly to that test server. I've got 2 pages open in 2 different web browsers. All right, this one here, Firefox and Chromium. As you can see here, both show me that it is totally secure. All right, everything is protected. And I think if we have a look in the certificates, I can't remember, no, yeah, more information, we can see this one is issued by Google, the same over here. So now what we're going to do is we're going to apply this to VLAN 37. It's going to remind me I need to go and get this certificate to download. It wants me to actually go and do something with that. So let's just grab that. There we go. Oh. I think I just needed to tell it that I had done it, and then it allows me to proceed, and this is now activated. So everybody goes, well, that's easy, that's all I needed to do. Well, let's have a little look and see, because I think my little test box will drop offline for a moment, and we'll probably need to reconnect. So just give me a moment. We might need to just jump on the server and actually do it from there, because again, the test environment that this is in is also using an SSL certificate. That's okay, here we go. All right, so it's come back to life. Let's let this drop back into place. Hopefully we can connect to it in a moment. Let's just try again. It might be a little bit grumpy. If it's a little bit grumpy, let's just go and grab the one that's here. All right, so let's just do it on here. So here is our one now. Now immediately we get this issue. All right, it's actually suggesting that something isn't going on well with this. And if we can actually see this, this actually says it's an MITM. So there's the acronym for you. All right, it is a man in the middle. attack. So what is happening is the firewall, and I'll just get it on a bigger screen here for you. The firewall is now intercepting this, but Google and other websites are going, hey, hang on a minute, something is going on here that shouldn't be going on. Some will allow you to accept this and go on, others won't. If we try and look at the certificate of what's actually going on in here and have a look at more information, again, Google is still trying to issue it, but we haven't allowed ourselves to go here. So we can't actually at the moment go there. And if we look at this, we can see it's the Ubiquiti certificate. Why? Because this is being provided by the EFG. Now on this side, I've installed the certificate. So I downloaded the certificate and actually installed it. So if we now refresh it to the Google page on here, we don't see actually anything different, but we do if we investigate just very slightly more into this. So if we actually have a look at the certificate that's valid, we see it's been issued from Google, but it's actually been the authority stamped by Ubiquiti. So what this means is as far as the devices are concerned, they have got a full pure point or end-to-end encryption happening. But what's actually happened is that the device is now encrypted to the EFG. The EFG is unencrypting it or de-encrypting it, whichever way that is, and then re-encrypting it, and then it's making a connection from the EFG to the destined website. That now means we can actually see inside this and get some feel for what's actually going on. So that is a very simple setup, but as you can see, the key there is now we've got devices that we maybe can't put certificates on. So you're going to need to think ahead of a way around that, either moving them onto separate VLANs or figure an alternative way around. So if we come back to our dashboard now and we start to look around in our inspection, then we should start to be able to see everything that's going on now. Everything that was encrypted from that computer, we didn't realize this much was going on, was actually happening. And now we can actually have a look and see. And we got all those same options for blocking that were there before. It also, was it in a risk? No, it wasn't. What computer has done it? And so now we start to see a very simple but easy amount of extra information going on inside here. Again, it will open up what we see in our intrusions as well. So now what I want to show you is what we can do a little bit more with this as the next step, and then we should be able to go on to compare it with some of the other vendors that are out there. Okay, so the next step is what can we do now we can see inside this? And we can actually do, obviously now, some filtering. We can also do some blocking of what's going on there. So we can now start to create simple rules. So at the moment we just did this as one simple rule. Maybe we want to actually start to create inspection profiles and actually create those the same as we've seen, but we can create groupings of these. So we can create target networks in here as our VLANs and specific target types. So it's the same options that we had before, but we could create different policies for each of them. We'll stick at simple because I can just show you this next bit that's going on here. So we're going to create an action. We've got queries, blocked file types, and blocked URLs. What do we want to do? We want to track it, or do we want to track and block it? So let's do a query. So example, search query. Are the tech geeks? Let's do this. All right, just to make sure we don't query and get it confused with anything else, let's grab that. Test query monitor. Okay, so now that we've done that, let's go back to our, we're going to apply our changes. Probably means that my test box will now drop offline, maybe, hopefully not. It has. Yeah, there we go. So every time we do some of these changes, it rebuilds itself very, very quickly, which is a little bit frustrating if you're doing a remote session. But let's just see. You'll see that a few times, and it does take a little bit for it to come back. I'll give it that. Every device that's based on an operating system potentially has to rebuild its rules, and I am doing this as a remote session. So we'll just hop back over to this box here, and we're going to use the one that's actually got the certificate in it because we don't have any reason. We're using this as a certificate based one. So let's put are the Geeks, the best Ubiquiti supplier. All right, and it's going to give you a whole bunch of other options in there. All right, and what people think. If we now go back into our insights and our inspections, I think it's our inspections and our queries. All right, if I've written that, now you can see I've actually been able to see that a user typed that information in and it did a query. And I was able to record that information. So maybe you've got keywords that you're looking for. Maybe this is in a setup in a a work environment, and you're trying to monitor for people looking for other jobs or whatever. That's how you can now look inside those packets of information. So let's now build it a little bit further and go, well, okay, we did that with it. What could we actually now do again? Now we could actually change this to be a block. So let's track and block that and apply it. So we're obviously going to go back to here again. Just give it a moment to apply it, and let's try and see if we can do that search again. Immediately, I cannot go there because it has now been intercepted as a block. So following that same scenario, we could have created another rule that was to block a specific file type. There's a lot of different file types generated there. Block a specific URL or a category. So this becomes a little bit better here. We didn't see many categories when we did this in HTTP, because again, a lot of those were probably going to be limited because they'd move on to HTTPS. So now we've moved into this. Now it starts to become a much more useful solution. So yes, we didn't get a lot in our basic when we're not using SSL inspection, but now we're using SSL inspection. Now I can create something in here. So this is my default workplace content filtering. So now immediately I can go, okay, well, I actually want, what do I actually, default content filtering, can't be more than 32 characters, brilliant. So maybe I want adult, maybe I want to block gambling, games, probably not that one. Maybe I do jobs and careers. Let's have a little look on here. Search engines. So we've not got a huge number of options in here. We haven't got anti-hacking or hacking and other bits and pieces along those lines. They don't go down into subcategories, but maybe we do e-commerce and shopping. We can build something in here that's a start, and maybe we'll get more of these in due course. So I have now built my content filtering block list, and so if I now apply that, I can now again block with the same block that you would have got on here. If I've tried to go to a shopping website, it's going to actually stop us loading that page. So now becomes much more useful because we can use the inspector here in inspection to actually start to see our queries. We can see everything that was in here. We can see that we actually now have blocked it. But even on our allow ones, we do have those options in, again, to block destination domain name if we wanted to. So we could have blocked all the traffic to it and created a rule around it. All right, Google is now blocked as a whole, and we'd need to come back to our security and our firewall rules, and we'll find that Google is now blocked and you can't get to Google whatever you want to do. So let's just have a little look, and let's just try and even just get to google.com. All right, and we can see there again we've just got a restricted page. It's trying to load, but nothing's actually going to happen because it is blocked. Obviously we want to get rid of those two there, so we can just manage these and actually remove them there. So probably that has brought me to the end of showing you how you have a good amount of firewall control in here. I want to just show you maybe this is a comparison with a couple of other firewall vendors of how they approach some of these bits, so you can just see a comparison of what can be done with a mainstream firewall vendor. But obviously some of this is still relatively new to the market and developing. I think it's got a great lot of features in the right direction. And let me just compare some of those for you as we go into the next section. So just thought I'd just maybe spend the next 20 minutes just doing a basic my thoughts of what I've seen with the EFG against some of the other firewall vendors that we sell, and just some of the points that you get in a subscription-based model, or maybe a firewall vendor that's been around a little bit more, just to give you an idea of what you might be missing, but also just seeing whether it still ticks the box for what you have, because I think it is a great option. So what I've just done first is just create a very simple comparison table here out of the main firewall vendors that we sell. So what we've got to remember is that the EFG is subscription free at this moment in time for what I have shown you. If you want more up-to-date signatures and that, then they will have a subscription model. I've seen lots of people go on YouTube and just balance this all around. Hey, but this compares with a $17,000 Fortinet here and a $20,000 whatever here. I don't think that's necessarily quite the right approach. I think it's probably looking at what this actually looks like, certainly at the entry level, because this really is a cost-effective unit. For all the vendors that we're looking at on this page here, you need to have application control, you need to have intrusion prevention as a service. Those are subscription-based, and so that pushes the model up, price up. Now, obviously, with the Ubiquiti, you do have limited support or warranty of about 2 years on these devices, whereas with these subscription models, while you keep the model going, you get warranty, you get firmware updates and everything else, although with the EFG you get firmware updates for the life of the unit for free. So there is a balance there, but let's have a little look on comparison. Remember, we got a comfortable 6 gigabits a second of throughput for the EFG with intrusion prevention running. We also got a comfortable 2.5 gigabits a second with SSL running. Remember, the EFG has got two 2.5 gigabit a second Ethernet ports, two 10 gig and two 25 gig. All of these devices that we're looking here out the box just have 1 gig. So let's compare it. There you go. You've got a WatchGuard on there. That runs at about 800 megasecond, probably about 500 megasecond from our testing with SSL Inspection running on it. The Fortinet has a bit more of an approach like the EFG, so only generally has some of the services running on Firewall Rules in the main ports, not across the board. I'll show you that difference in a minute across the firewall vendors. So this is probably the entry. This will do about 1 gig a second, so it should be good for you. Sophos, the 136, you'll see a performance review on our website. That tops out at 600 megasecond. And then the SonicWall, again, will do about 1 gig a second with most of the services run on. If you run it into totally secure, then it will probably sit at about 180 to 200 megabits a second. So there is a great opportunity here in what we're looking at to fit this firewall in, or this entry-level firewall enterprise router from Ubiquiti, because I do believe it hits probably 70% of the requirements of many people, and most of those other ones may not always be used. So I'm just going to talk about a few of those differences now. So I think some of the key things that we probably want to focus on is the visibility of what we're actually getting with the device when it comes to the subscription or the IDS signatures that are on there. Now, obviously, like I said, we're in Australia. We don't have the privilege of being able to subscribe to the updates on this, so we can only go by what is actually showing to us in the system, and actually have a look at how this is actually operating, and whether it's up to date, and all that we can see really with inside this, and maybe looking at some of the log files and the security detections, and you can see some of that stuff is actually happening with inside here, which is great, but it's going what else is going on with inside this to make it work. So I don't know how many signatures I get as part of the subscription. I don't know when they were last updated or how active they are. If we look at some of the firewall vendors, so for example, this is a WatchGuard, you can see it tells me that this was last updated today. What version it's on. It shows me how many objects have been scanned. So even in intrusion prevention, how many scans have we presented? Tens of millions of scans have happened on this network. I don't see any of that at this moment in time. You might be able to see some of that in the syslogs, but I've not looked. But it at least going to show me a little bit more. That's probably one of the things you're going to be missing across some of the difference with the EFGs. Don't seem to have some of that visibility. The second thing for me is logging. Now look, logging is pretty good here. in insights, and obviously in logs that I've shown you here, we do get a certain amount of things around security detections, some of the updates if we've done firmware updates, and then go into insights, and looking in insights and what do we see with inside inspection here. If there are intrusions, what do we see as our block queries, what's allowed. Remember, this is really HTTPS and IMAP-S and POP-S unencrypted stuff, and maybe stuff that was actually blocked as well. But other than going, in my understanding, I might be wrong on this, is going into the console itself at command line or dumping this out to another log server, I am missing some of that more granular information. So if we were to look at say a WatchGuard again, and look in traffic monitor, I can see all of this useful information streaming by, packets that are blocked, packets that are load, where they were going, what was actually happening with them. If I was to do this again in a Sophos, we'd get the similar type of thing. This tends to open in like the world's biggest web browser window. So let me just scroll this back down again and bring this in. So I get the options with inside here to say, well, I'm actually interested in IPS. Show me what logs here are about IPS. Again, there's not enough traffic going through this to show you that. So I can actually see, and I can use this to analyze. I can dump this out to Wireshark. So across that bit, I get probably a little more anxious. But having said that, what I don't get on these guys, even if I maybe look at a control center, I can see a certain amount of my application flow happening. I can drag down into some of the things that are actually happening inside my firewall. I can get some of the reports that are going on. This is inside of Sophos. I can see my applications and everything. I can see what's running. And all of this is really, really beautiful. But if I compare this with maybe what I've got over here, which is in the dashboard, I've got a list of applications. I can see what devices they've come from, and I can actually immediately choose to block this app if I want to, and it's going to write me a firewall rule. Now, SonicWall do have, I think, an option in theirs to write it from some of their logs or create some of the rules from there, but generally, you don't see that in the firewall vendors. So we sort of lose some of that granular logging for packet inspection tracking when you're trying to set up forwarding and things like that. But if most of your traffic is outbound, i.e. just you've got users browsing and data coming from cloud services, then you probably don't need that. And the skill and the speed to be able to change things directly here with inside this application probably outweighs it. So that's my two bits there at the moment. Then I think it's more object management. So we do have a limitation, as I showed you here with inside profiles. We can create IP groups, so we can reuse those. But when we looked at some of like our NAT rules that we were actually looking at, we were limited here in what we could actually use. We can use a network item here, even if we change this to say this, we can choose a destination, all right, and actually we have to still put in here a IP address. Now we actually created over here one of those additional IP addresses, and that would have been really nice if it could appear in here. Now, interestingly enough, in source, you can use it, all right? But that's not what we wanted. I actually want it from the destination. I would have really liked to be able to use that in there. It's also that same that we did in firewall groups as well, where we can reuse entries. And I think we do have some limitation of what we can do here, but I would have really liked to have been able to use multiple groupings together. So if we look at something like this in a WatchGuard, for example, in our firewall policies, we can create and add a policy here, and we can add a custom policy, and we can build this onto a whole range of ports. But once we've added that range of ports in, we can actually add other items to our custom rules. So if we create a rule that's in here, we can edit this and add more to it. So it becomes a little bit more dynamic. So I think that there is that as a thing as well of how we can reuse a little bit more than just a few ports and a few IPs. So that's another area that I think there is a difference there. Then I think it's about how granular you get with control. So in our firewall rules that we had here, realistically, this is more about accepting and rejecting. Our IDS, if you remember when we turned on intrusion prevention, it was across all of our networks. And it didn't allow us specific machines or anything else like that. If we look at maybe even in a Fortinet, and we look at our security policies here and a firewall policy, what we can do in here is we can actually apply it what we want and create multiple policies for them. So maybe we want a web filter on just one segment of our network, but now we can choose a custom content filtering setup that we can do, which we can define. For instance, in web filtering here, we can create a new policy, and in here we can choose from a long list of groups. It allows us to create slightly more unique control. Now, I understand the EFG is driving more towards applications, but really I want to be able to have some control over the actual websites. Now, they do give us some of those categories. You remember I gave you a block list, but not as much as here. I would like to be able to see a greater list to be able to, or be able to categorize and drill down. We see that in the same as, application control, although I do think actually the application listing is really, really good inside the EFG. So I think the granularity that we get from being able to create port groups, from being able to create multiple policies, we do get some of that. We did that before here in our firewall rules here, that we were able to create, it was in our next AI, we were able to create different content filtering, and if we move this to advanced, we could then create multiple policies and apply them differently. So we can get around it, but there wasn't, if you remember, quite as large a list as we would see in here. So that's something, again, you're going to get with the subscription model. You're paying for it, you would expect to get a bigger list. So on NAT, it's probably one of our other ones, is done very slightly differently. So in a WatchGuard, we might do something called SNAT. We might create an SNAT rule that we can use in a firewall policy, and then have a look at what we've created in this firewall policy. The SNAT is reusable, and then we apply firewall rules to this. This makes it really easy because it means we can again define an object and then apply our firewall rules over the top of it. So we did find that we could actually do some of that as long as we were very specific and stuck within a named protocol, and didn't just assume that it was everything. So it does generally work, it's just slightly different approach. Sophos have, covering those, the same things we have. They have hosts and services. We can create plenty of hosts, subnets, physical ID, IP addresses as servers. We can group them together. We can create fully qualified domain name lists, which is great for your blocking of, things if you wanted to then use it in a rule together. So we have all of these slightly different ways of approaching it. Our policies are exactly the same. Sophos has a NAT Rule policy, and you'll actually see this across all of the vendors. It really doesn't matter which vendor we're actually looking at. The same thing happens if we look in a SonicWall. This has logged me out, but it'll log me back in again. And we go and create a NAT object. We have exactly the same way of doing it. You really isn't much different here in the world of NAT, if you like. Source and destination, changing ports. All right, source and destination, changing ports. If we add a NAT rule here, source and destination, do you want to change ports? This has extra features for load balancing and that, which can be useful later on. Similar in the Fortinet world of doing things. And then you'd build a firewall rule over the top of that NAT rule, and those policies are pretty much the same. It's again slightly different way of doing it, that you create a firewall rule and then you add these policies in. So inside here, this firewall rule, then I've got the different application rules that I can apply to it, different types of IPS that I can apply to it. Now, again, to a certain extent, you could probably do a large percentage of that with inside here, because we could, again, create a outbound firewall rule, and we could choose what protocols we were going to use, or maybe I think it's mainly protocols that we've got on that. If we change it to simple, then we could obviously change it to different apps, app groups. So there's some ways, again, we could get around it. But those are probably things that have been caked in for a longer period of time with some of these main firewall vendors. So I think it comes down to me. Some of it comes down to it visibility, a slightly different approach. SonicWall have an approach of actually setting security policies across zones. So you can apply your antivirus and your everything else across a specific zone. And if that's the WAN zone, then again, anything that's in that WAN zone gets that security policy. So look, that's my little balance here. I think this comes down to what are you trying to achieve. If you've got inbound traffic and internal servers, then potentially the EFG doesn't necessarily give you so much granularity. It gives you a good amount, but I think you will get slightly frustrated with it. If most of your stuff is inbound and you want to control applications and rate limit, the main firewall vendors don't have the click and shoot simple solutions really that's already been built into the Ubiquiti that you've seen from the dashboard and building it. And I think that that's where this wins in many scenarios. So I hope you found this ramble through things useful and you got something out of this. This is not a this is better than this type of idea. It was really to show you here's four mainstream firewall vendors. What can we do in comparison? A good walkthrough for what you can see in the EFG, and then maybe just some of those key areas that I think some of it is the granularity, the visibility, the logging that isn't totally there for stuff that isn't just web based, and knowing what signatures I get. Remember, signatures themselves won't stop 0 day. Your ransomware styles, things that happen, or cryptoware that happen on the fly, those are done with sandboxing. It's a slightly different side of things, but I'm sure we will see those come in due course to the EFG. Head on over to our YouTube channel. We've got plenty more videos over there. Subscribe and stay up to date.